Once in a while, they're aggressive. Well, that said, let's get started. We've got quite a bit to cover tonight. Let me turn this music off, wherever my mouse is. Oh, I've got two screens here that it alternates between. You might get out handout 4. All it is the list of powers. And you might spend some time until you get to the point where you recognize those numbers. It'll really save you a lot of grief in the long run, if you will. It's almost kind of like you needed to learn your times table while you were in grade school. Well, you need to learn your powers now. And in particular, ta-da, you need to learn what we call the set of perfect squares. Okay? Now, the set of perfect squares are numbers like 2 times 2 is 4. So 4 is a perfect square. 4 times 4 is 16, or 4 squared is 16. 16 is a perfect square. This column right here are all what we call perfect squares. Okay? Now, look at this. If I take the square root of a perfect square, look at what happens with the answer. What a square root does, it divides the power of the number in half. Basically, 4, 2 squared, so you get 2. 9 is 3 squared, so you just get 3, or 3 to the first power. Because there's a hidden first power on all of those. Okay? Well, 49, which happens to be 7 squared, the square root of 49 then is 7 to the first power. So the square root of 7 to the second power is 7 to the first power. You see the pattern I'm trying to relate to you? So a square root is basically having the power of whatever that number was. Okay? And later on, we're going to deal with exponential powers and the way to convert between just square roots, cube roots, fourth roots into fractional powers. And it looks complicated on the surface, but it's really not quite as bad as you might think. Okay? Now, as we go down here, we see all of these numbers squared equals something. Look at this bottom. I squared, by definition, equals -1. The square root of -1 equals I. That's the same here. 25 squared is 625. The square root of 625 is 25. I squared is -1. Square root of -1 is I. Now, how we're going to deal with this bottom one is, let's say you had the square root of -9. You can't have a negative square root. It becomes what we call an imaginary number, a non-graphable number. You cannot graph it. Now, theoretically, it exists, and we can manipulate it, okay? But it's not a real number. You heard me talk about real numbers, both in that video and other stuff. Well, where do those strange numbers they talk about on the other side of the mountains? We're there, okay? Well, back to this. When you see a negative under the radical, you can extract it. This is just my notation. That is not anything official notation. That's just the way I do it, so I don't lose track of stuff. This gives me an I. That negative, technically, we're talking about -1 times 9. Okay? And that -1 becomes I. Now, on the other hand, the square root of 9 is 3. So we've got I times 3, or better worded, 3I, because we always like to put the number first. Okay? And that's the way these work. Now, that's not so hard, is it? Okay? Well, let's keep going. See if we can make it a little more challenging. Yeah, right. I can tell you're thrilled. Here's some questions. What's the square root of these real numbers? Well, 25, I've got it done for you. It's 5. Okay? -5 is also a square root of this, because -5 times -5 is also positive 25. A little bit later, we're going to take the square root of both sides of an equation. You know, the old rule, as long as you do the same thing to both sides, you're good. Well, what's going to happen is we're going to take the square root of both sides, but when they do that, because of this idea, we have to make it plus or minus 5. Okay? That's ahead of us a little bit. Okay, square root of 49 better be 7. Now, it could be -7. Okay? You could express that as the absolute value of positive or -7. But what we do usually is we almost always use the positive side. We call that the principal square root, as in the primary square root, compared to the negative side. Okay? Now, here are some more notations. I think I've got one more thing that'll show up if I click this. There we go. What if I have square root of -9? Well, in this case, remember we've got these two rules. Square root of -1 is I squared is -1, which I had down here. So let's apply it to this. The square root of -9 is -1 times 9, just like I have up here. The -1 part of that becomes I. The 9 part of it becomes 3. And then, boy, is that one sorry looking 3. So, and by the way, that is an interim step right there, but you don't need to ever show that. Right here's the way I would go, okay? I wouldn't even show it as -1. I just take that negative and pull it out as an I. And then whatever you got to do with this one. And it won't always be as nice as this problem. Okay, questions on this slide before I go on? Do any of you need just a moment or two to either copy or take a picture of this? You will have problems where 169 is a number in the problem, and you kind of got to know that 169 is 13 squared. Same way with 144. Same way with 625. Those are numbers that will show up on tests. Okay? All right. Identify the square roots of these real and imaginary numbers. Square root of 64 plus or minus 8. Square root of 16 plus or minus 4. Square root of 1 plus or minus 1. Square root of negative 100. That part is 10. That part is I, so 10i. And it is not a real number.
Question.
Yes.
Do you want us to, like, if it ends up as an imaginary number, do you want us to put the real number as well?
Well, it depends on the wording, but generally, if I see 10i, I know it's in real.
Okay.
But it depends on the wording in the problem. It says, is this answer a real number? Well, yeah, you better put a statement like that. Okay. Here's just repeating what I remember when I said the principal square root. That's just the positive side of it. Now, look at this one. What if we put a 25 in there? The answer would be, for the square root part of it, 5. For the negative, it would just be a negative brought down. If it's on the outside, looking in, all you do is bring it down each step. Okay? If it's on the inside, then it becomes an I. But if it's on the outside, you just bring it down, and it's times whatever the answer of this thing is. Okay? Now, square root of 0 is 0. Square root of 36 is 6. The principal square root. Ooh, square root of 4/9. Huh? Huh? There's actually 2 different ways of working this problem. Okay, there's the easy way and the hard way. But I've got to take just a moment to tell you guys something. Did you know that there are 3 laws of square roots? And these same 3 laws apply to imaginaries. Yeah, really. But not real. Here are the 3 rules. First rule. Thou shalt not leave a perfect square under the radical. Second one. Thou shalt not leave a fraction under the radical. Third one. Thou shalt not leave a radical in the denominator. Okay. Pardon my fake voice. Thought I was going to quote who?
Gandalf.
Actually, that's more like Moses. Oh.
Yeah, 10 seconds.
Okay, well, anyway, how are we going to deal with this one? How are we going to deal with this? Well, one way of dealing with this is, since this is a perfect square and that's a perfect square, I can extract this and I can extract that, and I'm done. Okay? Now, the other way I can do that is I can multiply this by 9/9. What's going to happen down here? I'm gonna have 9 squared, right? And up here, I got 4 times 9. Okay, now 9 squared, the square root of 9 squared is 9, right? And 4 times 9 is 36. Okay, all over 9 now. And 36, by the way, is a perfect square. What's the square root of it? 6. So this becomes 6 over 9, which reduces to 2/3. I told you the other way was harder. Okay. We're not perfect squares, I think is what you meant to say.
Yes.
Yeah, except you still might end up with a radical in the numerator when you're done. I mean, it just depends on the numbers. There's almost always more than one way of working these problems. Okay? Well, here's theirs. What about this thing? .2 times 0.2 is 0.04, because you got 2 digits behind them. Remember my house, upstairs, downstairs, take it to the basement. When I take 0.2 times 0.2, and here's the basement. So I've got 4 places down here, or 2 places, one here, one there, makes 2 places, so 0.04. Okay. All right, well, anyway. You need to learn to recognize those with the decimals in them also, okay? And the decimal points, when you're dealing with square roots, got to move by 2 decimals at a time, okay? Well, let's go on and see what they show us on this one. Okay. Square root of 81, 9. 36 49s. Square root of 36 is 6. Square root of 49 is 7. We're good. Square root of 0.09. Well, that's 0.03 or 0.3 times 0.3. Okay. Uh-oh. Now that thing is going to give me 12. And that's going to give me an I, so 12I. That looks more like a 7 than a 12.
I mean, you know, some dB.
Well, no, I'll tell you what's going on is trying to write on this while it's jiggling with my pen. That's why my penmanship is so terrible. Well, my penmanship's terrible anyway. That makes it worse. Okay, and this one again is not a real number, meaning it is not graphable. Okay, this one is just simply -12, and you don't really need to show those 2 steps. But as you see, we bring that negative down every step. Okay, this one, 0.1 times 0.1, right here, and I. And once again, that is not a real number. Uh-oh, got a fraction under the radical. We shall not have that. Well, what's the square root of 1? 1. What's the square root of 9? 3. The answer is -1/3. And again, I don't care whether you show those two steps or not. They're pretty obvious. Okay, very quickly on these. 9i, -8. 0.5 there with a negative in front of it, -0.5. Ah, yes, 1/2. 1/2 times 1/2 is 1/4. Okay, 1/3 times 1/3 is 1/9, and so on. And then I. Okay. Now we're going to talk about that stuff. Yay. Okay. This is actually, I had this on the board earlier. 2 is a third root of 8 because 2 to the third is 8. 2, 4, 8. Exponents are the one time that math teachers don't care if you count on your fingers. But what you're counting is the powers. Let's say I wanted the 7th power of 2. 2, 4, 8, 16, 32, 64. It just doubles every time, doesn't it? 128, 256. I'm actually up to the 8th power now. 512, 1024. You realize that is the 1024 is the number when it becomes a kilobyte, and then 1024 kilobytes become a megabyte, and 1024 megabytes become a gigabyte. Computer wise, they are a decimal system. Actually, they're a hexadecimal, but anyway. Okay. So anyway, you need to be able to count the powers. Okay. 2 is a 4th root of 16. Why? Because 2, 4, 8, 16. 2 to the 4th is 16. Now, if n is bigger than 1 and is an even integer, and if this number is a positive number, that's what that says, then this is the principal root. Well, that's gobbledygook for whatever we said right here. 3. All of that just means this. We use the 3, not the positive 3, not the negative 3 for the principal root. Okay, now, if that is an odd integer, then you can have negatives under the radical, and it's okay. For example, if I had the cube root of -8, the answer is -2. Why? Because -8 is -2 times -2 times -2, right? So the square root of that, the cube root rather, I got 3 of them, so that's what it is. Okay?
So if it's not the square root, the negative under the radical is not imaginary.
That is correct. Because you can have negative cube roots.
Okay.
Because negative times negative times negative is negative. What about a 5th root? Maybe. Okay. Let's play with threes. We've been playing with twos. I'm getting tired of twos. 3, 9, 27, 81, 243. 1 times 3 is the 3 on the end, and 3 times 8 is 24. Okay. 243. So that's the 5th power of 3. Now, if I made all of those negative 3s, negative times negative is positive, times negative is negative, times negative is positive, times negative is negative. So you can, if it is an odd root, legitimately have a negative answer. If it's a even root, 2, 4, 6, 8, 10, whatever, then there's a good possibility you're going to end up with an imaginary. Okay. Did that answer your question?
Yes.
Okay. Well, here's what I just did. Okay. Oh. 0 to any root is still just 0. Yeah. Okay. Answer is 2. Answer is, this is one you better learn because you will see it over and over again. 4. 4 to the 3rd is 64. Okay. 4 to the 3rd is 64. It's right here on your exponent sheet. Nope.
No. This is positive because there's not a negative under the radical.
Here's the different ways you can manipulate this thing. Okay. Fifth root. 2, 4, 8, 16, 32. 32 is the 5th root of 2, or 5th power rather of 2. In this case, because that is an odd root, the answer is -2. Correct. If it's an even root, then you may have to deal with the imaginary. Squares, absolutely. 4th, 6th, some of those. It's not an always rule. It's a probably rule. Okay, 4th root of 81. 81 is the 4th power of 3. 3, 9, 27, 81. Okay? You didn't know you'd be learning multiplication facts tonight, did you? Well, so what are we going to end up with this thing? Well, the answer is just going to be 3. Count the zeros. Answer is 1. All right, excuse me, 10. 10. Because a million is 10 to the 6. Brain bubble. Okay, what do we got? Well, that part of it is 10. 10i. Okay, here.
No.
2i. Yeah, because 16 will break down. Because you'll not leave a perfect square. That is a perfect square. Okay. Now, do you need to show all of these steps? Heck no. Can you go straight from this one to that one?
Yeah. If I didn't know that, like off the top of my head, how would I do that?
Figured which out.
How do you have to?
Well, right here it is, okay? In this, we broke this -16 into -1 times 16, which is 2 to the 4th. Okay? And here, 4th root, 4th power. So that 2 comes out perfectly. Okay? Now, if this were a 5, I'd have 4 of them come out perfectly, and I'd still have a 2 left under the radical. And we'll get to that in a moment. We're not there yet. So here's this thing extracted, because this power and that power match. Now I got to deal with this, and it's I. Okay. Did I answer your question even remotely? Okay. Well, what's the answer? 2. What's the answer? 10. What's the answer? -1.
Oh, yeah.
-1. Odd power out there. What's the answer? 2. What's the answer? What's the answer?
6i.
6i. What's the answer? -3. Okay. We're getting fancier. We're getting fancier. 4th root of this thing to the 4th power. What do you think the answer is? It's the absolute value of -3. Okay, we've got the same power here, but we've got a negative in here. Now, what this is saying is, if you take the absolute negative value of -3, what is the absolute value of any negative number? The positive number. So ultimately, what is the answer on this thing? 3. Now, another way of thinking about this is -3 to the 4th is +81. And the 4th root of +81 is 3.
Gotcha.
Okay. Okay. Read this. Read this. Now, what that means is if you just have a problem, let's say you had 9x squared square root off. That's going to give you a 3, right? This is going to give you an absolute value of x. That's what this rule is saying. Now, what is the absolute value of x? Ultimately, it is just x. But you will have a test question, maybe on the final and for sure on my test, that you have to do this business. Okay? Oh, I guess I better erase that. Same power. Would it? Or would it be -3? Remember, odd powers, you can have negatives. So the answer is -3. Okay, what about this? Well, the answer is going to be technically that. But what are we going to use from that? Oops, it's not up here. Ultimately, it's going to be x plus 2. Okay. You're taking the square root of a square. So it's the radicand. Say again?
I said to get it out of the absolute bars.
Yeah.
Maybe that's what's good.
Okay, what about this one? Cube root of a cube. Answer is a plus b. Square root of y to the 4th. Y squared, ultimately. Okay. In other words, the square root does half this power. And again, you don't have, most of the time, you don't have to show these steps. Now can I go? Okay, what is this one going to be? Technically, absolute value of x to or y to the 4th, which becomes just simply y to the 4th.
Why would it be, why would it
Square root is half of that power.
You normally multiply exponent.
And if we use the power rule, I'm taking the square root of a square. Well, what's in there? Y to the 4th. That's just a different way of doing it. Okay, that's going to give me a 3, right? And that's going to give me an A. Ready? Okay, what about this one? Well, actually, this one's easy because all of these have a 5th power. Okay, the answer is going to be A over B. Now, this, since they're both the same power, can be rewritten as that. Since they're both the same power. A different process. So we haven't done it yet. I'm not trying to be flip, but I mean, it's a whole bunch of different steps. And I will get to them, just not yet. Okay. Oh, then we're looking kind of nasty evil now. Well, this negative, we're just going to keep bringing down, or over as the case may be. Okay. Now, this 81 is a 3 to the 4th. This x to the 4th is an x to the 4th. And this y to the 8th is a pair of y to the 4ths multiplied together. Okay, which is what that's showing. Okay. Now, what's the 4th root of 16? It's going to be 2, except that 2 should not be underneath that radical at this point. That's a mistake in the factory slide. Okay. So the 4th root of this stuff to the 4th power is that. And then we've already taken this 2 out. This, like I said, should have been that. Okay. This is an incorrect slide from Alex. I forgot to change that after last semester. I'll try to do that, but it's too late now. Huh?
The two's under all of it, then?
The two's under all of it because the fourth root of 16 is 2. 2, 4, 8, 16.
Putting in that parentheses means we have to deal with it as well with that fourth lane. That would just look really ugly.
Yeah. Okay. So anyway, that's what you got on that thing. What's the answer? T to the third. Here. 64 is 4 to the third, right? So for the 64 part of this one, we just got 4. 3 goes into 12 4 times, so y to the 4th. Easy. Okay, what about this one? Everything's fourth, so the answer is just simply x over y. What about this one? I got a negative out in front of whatever it is. 32 is 2 to the 5th. And a to the 5th, so in my numerator, I'm going to end up with 2a over b to the 5th. Or excuse me, b to the 2nd. Because 5 goes into 10 twice. Okay? And then that negative just comes down. We'll do that later. Okay, radical functions. That means equations with square roots in English. But we've got some skills to get first. Definition of fractional exponents. Definition of fractional. Now, I've shown you some of this already. And unfortunately, that part right there is off my screen. In these, square root is the same thing as half power. Because what do we do with square roots? Think back to what we just did a few minutes ago. If we had square root of y to the 6th, the answer was half the power. So a square root symbol is a find half the power symbol. Okay? The denominator, this problem right here, could be written as that. Okay? The denominator is always the degree of the root. If this were a cube root, there'd be a 3 there. If this were a 4th root, there'd be a 4 there. The numerator is always the power of the radicand, the number underneath the box. Okay? Now, that's the most important thing for you to remember. The numerator deals with the power inside. The denominator deals with whatever root it is. Okay, fancy gobbledygook, that's what I just showed you, except using letters instead of numbers. Okay, this becomes the denominator. The hidden power 1 right there becomes the numerator. Okay, this converted to radical form. That becomes the root. Here becomes the power. Technically, there's a parentheses around this to the first power. If that helps you any. Okay. Do you need to show this? Not as long as you're cool with it. As long as you understand it's there. Okay. And the answer of that, of course, is -2. What about this one? Well, that means the fourth root of 81. Well, 81 is 2 to the fourth, 3 to the fourth, right? 3, 9, 27, 81. So the answer then is just 3. And this and that mean the same thing, because remember, that's hidden. Okay? Where the numerator is. Okay, what about this one? We're basically talking about a square root, aren't we? Okay. Now, this one's a trick problem. There are two possible answers you could get, -10 or 10i. If you're thinking rightly or wrongly. I'm not being nice, am I? That 1/2 only applies to the 100.
Oh.
If there were a parentheses here, then you would get the 10i.
Oh.
Okay?
That would be negative.
Because then this would go under the radical. But the way this is written, that exponent only applies to the number or letter directly adjacent to it. Yep. Okay,
Now it's
ta-da.
10. Now it's
Kind of told you about that one already, didn't I? But what is the answer on this, even though they didn't show it? 10i. Okay, what about this one? There's there's two things going on here. This thing, as a power, is going to cause you to take the reciprocal of that. So this is the equivalent of 1/16 to the 1/2 power. A negative power says you've got to flip or take the reciprocal of the base. Okay, even if you have to put in that 1. This in turn is the same thing as that, which is 1/4. Okay. Looks like they did it just like that. Or lucky. Okay. So that negative is going to be under the radical, isn't it?
Yeah.
So this is, what is the cube root of -64? Well, 64 is 4 to the 3rd. So we have a perfect cube under there. So our answer on this one then will be -4. Anyone question that? How I got it before I go on?
Because with the last time you had perfectly 100, and that was 10i.
But this is a cube root, not a square root. This means that. And remember, when it's odd power roots, you can have negatives. Okay. Now you okay on it?
Yeah.
Whoops. Okay. 16 is okay here. Negative and square root of 36 is 6. Here, now you have square root of negative 36. This becomes I. This becomes 6. So your answer then is 6I.
The difference in the things.
Absolutely. Because here, that 1/2 applies to this whole thing. Here. Here, that 1/2 only applies to this, and you have to just bring down the negative.
Okay.
Okay, on this one, first thing I gotta do is that, which becomes that, and that's 4 to the 3rd, right? So then the answer is simply 4. Oh, yes, 1/4. I got careless. 1/4. Okay. Questions on that one? Well, I guess I'll erase. You can read this. If it's in English. Or if it's in math school. Hieroglyphics. This is the power rule. Now, what this is also a way of saying is what I explained to you already without showing you that. I've just told you this is the power of the numerator of the radicand, and this is that is the root. Now, does this matter whether that's outside with parentheses or inside? Ultimately, no. Okay. That's going to ultimately give you the same answer. Which, that's what this slide is saying, or step is saying. Okay, so what does that interpret as? 8 to the 2nd, cube root of. Well, this is 64, cube root of, so the answer is 4. Okay.
That's the part I have trouble with.
Okay. You okay on it now?
Yeah.
So that 8 squared root of 3.
Yeah. That's what I'm showing right here. That's always the numerator power. The denominator is always the root degree.
So root of 2 is always the
Uh-huh. Yep. And the denominator is always the root.
Remembering that.
Well, there's manipulation on it, which I just prefer to think of it this way. Okay, what about this one? What does this thing mean? 100 to the 5th square root of. Well, 100 to the 5th is 5 sets of 2 zeros. 1, 2, 3, 4, 5. That. Well, what did I end up with altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 to the 10th. Okay. Now, they're gonna show you a little different way of doing this, but honestly, this is the easier way. Okay, here we go.
Wait, why is it only 5 zeros? In the-
Well, I had 10 zeros and half of those is 5 zeros.
Gotcha.
Huh?
Yeah.
Remember, I had 10 zeros. And then I took the square root of 10 zeros, which gives me half of it, which is that. Just two different ways to approach this problem. Okay. This one. This applies to both of these. Because of the parentheses. Now, 1 to anything is going to be 1. So that's going to be kind of easy. See, ding, right there. I just write down this 1 and then I mess with this 25. But you do need, now, there is another way of showing this problem. This problem could be shown as 1 over 25 to the 3 halves power, or 1 over square root of 25 cubed. Okay. Now, 25 cubed is one big number. Right? But think of this way. What if I broke that? What if I broke this down? A 1 there and a square root of 25 to the second times 25 to the first. That'd still be 25 cubed, right? Right? This square root of 25 squared is 25 squared. That is 5. Okay? And so in this particular instance, you know, you're causing yourself a whole lot of extra work. So in this one, you're better off the other way. Took a square root of the whole thing. And in this case, you can take the square root of this. Okay. See, they're having it on the outside instead of the inside this time. That's why it's nice that you got that option. Okay, what about this one? Well, first thing we got to do is flip it. Okay. So now we've got that. Well, we can take the square root. We don't have to do both of these at the same time. We can take the root and then do the power. Okay? You don't really want to do it the other way. What's the square root of 1/4? 1/2. Well, now they did it the other way. Let's do it the way I was telling you you might want to consider. Square root of 1/4 is 1/2 cubed, which is 1 over 2 cubed, which is 8, which is 1 over 8. 1 over 8. Okay. So that's just two different approaches to doing this. Okay, here, I took the square root of that because I could. And then finished it, or here, I dealt with it in a more complicated way. Sure.
With this certain example, or some of those a little bit, you use the two would only go root.
Normally, always go with the root. The denominator is always the root. See, right here, when they change this, here's that power, but the root is square, which is the 1/2 power. Technically, there's a second on that symbol. You just don't see it. Okay, this one.
Not now.
Good
That
one.
one was hard.
Okay, see that even power? Okay. Now, what this thing really becomes is it becomes, there's the I, and this becomes -3, or excuse me, 3 square. Oh, wait a minute. I gotta get my thinking in order here. Okay, I can take the 4th root of that. If I take the 4th root of that, I get 3i, right? But I've still got that to the 3rd power, which technically would be 27i. That's wrong.
Wait, they got rid of the 3rd power under the root.
Well, that's the problem, is they didn't show the 3rd power. They dropped it. This dropped. Okay, I've got to watch my time. Converting, you know what, we've been doing that already. We've been doing that already by far. Went too far back. There. I mean, that to either of those, depending on which way you want to work it. Okay, now this one looks a little different. That means we're going to take the cube root of 5 to the 1st. And we're going to take the cube root of x squared. Or since I've got a cube in both of these, I can just say 5x squared to the 1/3. 1/3 out of this is just 5. 1/3 out of this is the 2. Which still means that since they're both cubes. Now, would I ever show this step going from here to there? No way. Now, will that thing simplify anymore? Well, 5 is not a perfect cube, so we can't do anything with it. And x squared is not a perfect cube either. So that would be all you can do on that.
Okay.
You ready?
It's like theoretically, there was a way that it came out to like, I don't know, 15x cubed. You can simplify that.
Well, I mean, you could take the cube root of 5,
Right.
okay, and it's 1 point something or another. I don't remember the number anymore. Believe me, at one time I did, because when I went through college, we didn't have calculators. We had to learn that stuff. But anyway, well, let's go on to this one. This 1/4 does not apply to that 3.
Why?
That's a big mistake that people in this class make. That 1/4 only applies to that y. So there's the final answer. You've got to remember, a power only applies to the number immediately next to it, unless there's a parentheses. Okay, what about that one? That 9 is not affected by that power. How many of you got sucked in by that? More than one of you. So let's just bring that 9 down. Now this z, technically I'm making it 1/z to the 3/4. Okay. Now, this in turn becomes 9 over, 1 times 9 is 9. 4th root of z cubed. You gotta watch this business. What does that power apply to? Just the number or variable right adjacent to it. Okay, well, here's some more, and we're gonna keep going. Okay. Convert to an equivalent by using rational exponential variables represent positive real numbers. Assume that they are all positive real numbers. Okay. That word always bothered me. You can break it into 3 syllables and it's dangerous. Okay. Now, what they're really saying in English is convert this to an exponential value.
Being recorded.
Well, we've got b to the 3rd over 4.
I guess
I can do this one.
Yeah,
this is
Okay, what about this one? That was just square root of 7a. I mean, you could write it as a half power, but you gotta put the parentheses so it applies to the 7 and the 8. That, by the way, cannot be simplified. Either way. This one.
Could you also write it 7 and a squared?
No. Because that 2 is a root, not a power.
Oh,
Is that like 5? No. Okay, this one, 7's external. That means we're just going to bring it, bring it down. Okay. So we're converting the square root of a to a to the 1/2.
So the 2's coming from the right.
Yeah, because technically there's a hidden 2 here and a hidden 1 there. Well, again, some more. Now, I've got a handout page for you. Don't copy this down. Get out your packet. Somewhere I've got a page 8. Okay. Yeah,
Is that right?
yeah.
It's been and then I give.
I actually may have a second page in here as well. Okay, well, anyway, these are the rules. Now, what you really need to do, these, if you look at your exponent sheet, I've got these rules on the top of your exponent sheet. Okay? This is the power rule. Here, same base, you add them. Same base, you subtract for division. Power rule, you multiply. Here, you got to take that times both of these. Okay? Here, you got to take it times both of those. Okay, that's all stuff that we've already discussed. Okay? Now, negative exponents. That negative makes us convert this a to 1 over a. Okay? What if I had 3/5 to the negative second power? Or negative 1/2 power? What if I had that? First thing I'd have to do is 5 over 3, 1/2, 1/2. Okay? Now, what about these? As long as you have a common denominator, you can add the numerator exponents. Now, 5/5 happens to be 1, doesn't it? So what's the answer of this? Just y. Okay. What about this thing? Does this 6 get flipped? Does this a get flipped? No. That negative only applies to this a right here. Okay. Now, my way of thinking on this problem is I've got this 6 here, and it's over a to the 3/2. And I've got to flip that, which will put it down here. Technically, that. This is technically that, okay? Times that. Or in other words, I've got this 6 over a to the 1/2 times a to the 3/2. Now, I've got a common denominator exponent. So I can add the numerator exponents. So this gives me 6 over a to the 4/2, which equals 6 over a to the 2nd. That's as far as you could go. By the way, this answer and that answer are the same thing. The default, hint, 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 the default is to have positive exponents. Okay, so this is a better answer than that. Okay, you're going to have a problem kind of like this on at least one test. I'll get out of the way in a moment. Oh, goodness. That 4 applies to all 3 of those terms.
Oh, boy.
Now, I'm gonna work it the way I would start this problem. It may not be the way they show you. But if I had this problem, this is what I would think. Okay? I would take S to the 4/2 power times T to the 4/3 power over W to the 12/4 power. Now, this one can simplify. S to the second. This is still T to the 4/3. And this is W to the 3rd. Right? Okay. What? Well, or you could have S squared cube root of T to the 4th, except you can take the cube root of T to the 4th. Okay, because there is a 4 in this. S squared cube root of T to the 3rd times T to the 1st over W to the cube. Do you see how that can become this? And cube root of T cubed is T S squared. This is hard writing backhanded. Just this T that I'm going to extract right there. Okay. I've still got a cube root of T left all over W cubed.
Yeah.
Not really.
No.
Not really.
Yeah.
Yeah. Well, sometimes you got to simplify. If you can, you must.
That one is the
What?
S squared.
Yeah, that's the ultimate answer. And remember, this is just technically T to the 1st. And that's a root. Okay, watch this. What's this? If you had to take that, okay, this is maybe going to help you to understand this down here easy. I can extract that one like it is, a T. This breaks down into x to the 5th times x to the 2nd. And I can pull the x to the 5th out. Okay? I've still got this x to the 2nd left in there. Here, I've got y to the 10th times y to the 2nd. And I can pull that 10th out as a y squared. Okay? Now, I've got this much that I pulled out. Here, here, and here. But I got some leftovers. You know, kind of like when you cook too much for supper. Well, I got too much in my pot. So I got some leftovers. Those leftovers are still under that 5th radical. And what leftovers do I have? I have an x squared and a y squared. Okay? Did that help maybe in terms of what I did down here? Okay, well, obviously it's time to go.